Everybody, um, welcome to my presentation. Before I start telling you a little
So good morning from Bangkok to everyone in this webinar. My name is Fran and I will be MC for today. I would like to welcome everyone to the third day of Regional Water Talks, and you are now watching the Thailand session. We will be discussed under the topic of the investment opportunities in Thailand's water service sector. So this session is organized by the Federations of Thai Industry, Water and Environment Institutes for Sustainability, together with Informa Markets in Thailand. For Informa Markets in Thailand, we are the organizer of the ThaiWater Expo, the Thailand's only international exhibition and conference on water and wastewater technology, which will be held in Bangkok, Thailand. So before we start, I would like to inform you a little bit of today's agenda. So during this 2-hour session, so you can be sure to get the insight on the government's water management policy and plan, the role of water management in circular economy, and technology that currently available. So we invited speakers and experts from Thailand and the Netherlands. So they will present with the presentation for 30 minutes per panelist, and we will keep 25 minutes at the end for the Q&A. Carry on to the housekeeping rules. So as you may already saw that for the camera and microphone are visible for the whole sessions. So if you would like to ask any question to our speaker, please put your questions at the Q&A box below, and don't forget to mention the speaker name so we can know which speaker we should address those questions. And without any further delay, I would like to introduce you to the moderators for today, who carry more than 15 years of experience in water resources sector. She is Assistant Professor Dongrudy Kosititiwong Kongskitpun, is an Assistant Professor in Department of Civil Engineering at the King Mongkut University Technologies, Thonburi in Thailand. So her background is in water resources engineering, and her research is mostly about the hydraulic engineering, the computational fluid dynamic, and climate change. She is also focusing on her higher educations and combining it with the interesting in topic of water resourcing engineering. สวัสดีค่ะ Dr. ดวงฤดี Yes, I would like to pass this floor to you.
Hello everyone, I'm Dongrudy Kosititiwong Kongkitpun. Very pleased to meet everyone here, and thank you so much for wasting your time with us today. Welcome to the Regional Water Talks 2021 in the topic of investment opportunities in Thailand's water services sector. Our goal today is to be sure that the participants can gain insights on the government water management policy and plan, the role of water management in the circular economy and technology currently available. So before the session starts, let me introduce our speakers with us today. The first speaker, Associate Professor Dr. Bancha Khwanyoon, a Dean of the Faculty of Engineering at Kamphengsan Kasetsart University in Thailand. He experts in water management, for example, on-farm water management, project water management, PIM or participatory irrigation management, groundwater management, system analysis, for example, simulation and optimization of the irrigation system, multi-criteria decision-making, hydraulic model and climate change, and extreme weather, drought control, flood mitigation, climate change mitigation and adaptation. So those topics are really interesting. The second presenter is Mr. Chucha Saitin. He's a Committee of Water and Environment Institute for Sustainability, the Federation of Thai Industries, and Managing Director of Amata Water Company Limited. He experts in water management for industrial estate, including water resources, water supply, wastewater and wastewater recycling system in Thailand, Vietnam, Myanmar, and Laos. And the third speaker is from the Netherlands. He's Mr. Sid Bolbert, a Chief Executive Officer of Elemental Water Makers BV, who are operational with their unique solar desalination technology in 17 countries. He's also a faculty member of Singularity University and also the chairman of the Elemental Water Foundation, and recently just received the Global Water Award from the Emirates of Dubai. So now is a good time to start with the first speaker. Let's welcome Associate Professor Dr. Bancha Khwan Dean of the Faculty of Engineering at Kampheng San Kasetsart University in a presentation on water balance assessment and national water management guidelines. Please welcome.
Okay, good morning, everybody. We're glad to have the opportunity to share my experience with you about the water management in Thailand and also the situation of the water demand and supply in Thailand right now. Okay, but I'm sorry to you that the slide we share on you will be mostly on the the water balance assessment. It's not much about the water management guidelines, but anyway, I will talk a little bit about the water management guidelines, which I am about a national committee on or subcommittee on management strategies. So I will share some of my experience with you. First of all, I would like to talk to you about the revolution of water resource in Thailand that actually is very slow, except the last 4 years. We have moving forward very fast. We have a new national master plan for 20 years on water resources. We have the Water Act, and we have Office of National Water Resources. That is quite new for Thailand, and it's a lot of reform coming after that. Especially we have written the 20-year water master plan. I will share with you a little bit. Sorry that I cannot share the slide with you. First of all, we emphasize on the domestic water use. That is the first priority. The second priority is the water for production. That is mostly for agriculture and industry. Third is flood control or flood management. And the fourth is the water quality and the conservation. And the fifth one is on the conservation of the national forest or the upstream area. And the last one is about water management itself. And right now, the next slide please. Right now we have transformed, the river basin in Thailand according to the new Water Act or water law. From originally we have 25 basins, but from this year now on we have 22 basins. And this I show you on the slide. It can be grouped into about let's say 4 big groups and 2 small basins. The first big group is we call it Greater Chao Phraya. The Greater Chao Phraya is the 4 basins in the north. From this picture, it's Ping Wang Yong Nan. It's number 2. Let's say what number? What 6, 7, 8, 9. That is the basin in the north. It is the branch or tributary of the Chao Phraya. And then the lower plain of the Chao Phraya is number 10, 11, 12, and 13. That is the Chao Phraya, Sakay Klang, Pasak, and Thajin. This is the most important river basin of Thailand because it's about 1/3 of the whole country. And the production of the country actually it concentrate on the central plain, especially for agriculture, commerce, and a lot in industry too. And the second group is on the eastern, northeast. Let's say northeast. It's number 3, 4, 5. That is a branch or tributary of the Mekong. And actually number 2 is also the tributary of the Mekong, because Mekong fall along on the northeast border of Thailand, between Thailand and Laos. This is the high, we can say it's a plateau, it's a little bit higher area, the land is a little bit less fertile than the Central Plain. You know, but but these really have a lot of population because the area is really big. And the next group is very important, and Khun Chuchat with us here today from this group is the Eastern group. Eastern group is you can see the basin here, that is basin 15, 16, 17. That is the new developed for industry area. You know, that is Bang Pakong, you know, Eastern Coast and Tonle Sap. You know, that is the one of the most important area right now for the production of Thailand, because it's highly populated from the industry growth, you know, and the government plan. And when you have heard about EEC, you know, right now it's concentrated on this area. Okay. And the last one is on the south. You can see from that here is number 18 to 21. You know, that is the south. You know, start from Phetchaburi, Prachuap, that is western coast, you know, of Thailand, up to the south to the last one, that is the number 31. That is the more southern to Malaysia. You know, and this one is on the western basin. You know, that is next to the Andaman Sea, maybe in the Phuket area, where you may know. You know, the other two small basin is number 14, that is Meklong, and that is, the other one is number 1, is Sarawin. Sarawin is flowing into Andaman Sea, and 14 is also flowing into the Gulf of Thailand. That is a new basin of Thailand. Okay. Okay. Next. Yeah, I will talk about each group of them. You know, first, Greater Chao Phraya is among the most important basin. You know, like I tell you, because it's 1/3 of the country area, and also the major production in terms of agriculture. A little bit of maybe 1/3 of the industry is here, or maybe more, and also most of the commerce in this area. Okay, and we have 4 major dams in this basin. On the map, maybe you see on the right, on the top, that is Silikit on the Nan River, and you have on the left, you can see the blue there is that is the Phumipon Dam. That is the 2 major dams. The capacity of Phumipon is about 12 billion, you know, and the Silikit is about 9 billion. That is big, you know. And we have another 2 dams that is called Granoi. Actually, it's just below the Silikit Dam. It's not, you can see the reservoir here, and the other one is called Pasak. It's on the Pasak Basin. That is on the right side of this map. Okay, so and the area, the total area of the whole basin, that is 159 square kilometers, and you can see that it's 8 major basin, river basin together combined to be Chao Phraya. Okay, next one. Yeah, you can see in terms of rainfall here, it's about 1,000 or a little bit over 1,000 millimeters per year. That's not so much, you know, compared to the average rainfall of Thailand, because average rainfall in Thailand is about 1,300 to 1,400, you know, cubic millimeter. You can see that over 8 basins that combined together to be Chao Phraya, the rainfall not so much different. But if you have a look at the runoff, you can see that the Nan River contribute a lot. That is about 7 billion MCM. You know, you can say 7 billion MCM. You know, that is million cubic meter. That's a lot. You know, and the next one is the pink. That is about 11 billion MCM. You know, that is a major tributary that keep the water. The other one can see that combined together still not so much water. Okay, next one, please. That is about the supply. This is the demand side. The lower one in the brown color is the demand side. That is a little bit, you know, that you can compare here. You can see that the supply side, it comes from the Nan River and the Ping River in the north. You know, but the demand side, you can see that from the brown, you know, on the most right hand side, on the Chao Phraya and on the Thachin. Chao Phraya is Bangkok actually. Bangkok is you know, the Chao Phraya River flows through the heart of Bangkok, and then Sub Prakan and goes to the Gulf of Thailand. And actually, Chao Phraya is have one tributary called Tajin. It separates at China and then go to the Gulf of Thailand too. These two basins is the most important basin in terms of agriculture. Actually, the water use shown in this slide that is around 19 billion cubic meter and 13 million cubic meter for Chao Phraya and Tajin is mostly from agriculture. I would say that 70% of this demand is on agriculture. And the other 30% mostly is on domestic water supply, on industry, and on environmental flow. Especially, during the dry season, we need a lot of water to push the salt water from, penetrating into the Chao Phraya River and Tajin River. Okay, next. Yeah, this is about the balance. You can see that we have deficit in the Chao Phraya and Tajin, a lot of deficit. But how can we survive? We survive because of we have the big reservoir. That is the four main reservoir that I discussed earlier. That is Silikit, Phumipon, and then Queno and then Pasang. That is supply the water during the dry season through the network of irrigation and network of Chao Phraya River, from the north to the central plain. And so we can say that the Tajin and Chao Phraya receive a lot of water in the dry season from the reservoir in the north. And actually, it doesn't show on the map that one of the water supply is from the west, that is the Mekong River. But sorry that I didn't show you on this map. On the Srinagarin and Vajiralongkorn is another water supply that support the Tajin and western side of Bangkok. Okay, next. Yeah, next I will talk about the eastern basin. That is important basin right now. The area is only about 37,000 square kilometers, but that is also quite big. But compared to the Chao Phraya, is much smaller. So it's three river basin here. The yellow one there is the eastern coast, and the blue one that is the Tonle Sap, and let's say the brown, that one is Bang Pakong, and the three provinces shown on the map, that is the EEC, Eastern Economic Corridor, that is Chonburi, Rayong, Chachoengsao, that is the developed area for the, let's say, the next 20 years and the new decade for the next decade for Thailand. Okay. Next, please. Yeah, this is about the rainfall. You can see that compared to the northern or the central part, the rainfall is much more. It's about 1,700 millimeter per year. You can see that the eastern part, that is about the Trat and Chanthaburi. You can see in the map that it shows you the Chanthaburi. That is the rainfall is much more. Actually, that area is about 2,000 or maybe more. And on the western side, that is Chonburi. That is about maybe 1,000, a little bit more. Not so, but on average, it's about 1,700 millimeter per year. And the annual runoff is about 18 billion cubic meter. Okay, altogether. Next, please. Yeah, this is about the water demand. The water demand, you can see that this is different from the other region of Thailand. You can see agriculture is about maybe 3 billion, let's say 3 billion. And the industry is about 1 billion, and the one for domestic supply is about, let's say, 500 million, and then another 500 million for ecology or for natural resources. Yeah. So altogether, we use about 5 billion cubic meter per year. Okay. Yeah. Let's talk a little bit more about the EEC, because myself have done a lot of work on the EEC in the last couple of years. And you can see here we give you some more detail about the water for industry, the water for domestic, and the water for agriculture. And you can see Rayong, Rayong is a good example that the industry is very important for Rayong. Basically, what to use in Rayong. It's the highest industry, about 500 million, and agriculture is maybe only 150 million, and water supply, domestic supply, only 60 million. And the other one is Chonburi. Chonburi, you can see that industry and domestic supply is not so much different, 300 for industry and 234 for the domestic supply. Agriculture is also less. Turns out a different story, the majority of what you is for agriculture, not so much for industry or domestic supply, and altogether it's on the underneath that about 2,500 million cubic meter per year. Okay, next please. Yeah, actually we have a little bit of water shortage in the Chonburi, or let's say East Gao sub-basin number 1, that is about Chonburi or Rayong, but this one have been solved by the Pi network. We have, sorry that I didn't show you the Pi network here, but actually the eastern part of Thailand or the EEC area, we have a very, very dense Pi network connecting most reservoirs together, connecting the industry area, and the urban area with the reservoir and with the another river basin that we divert the water from the Babakong and then the Chantaburi area into this area. So far we have no water shortage because of water diversion in this area. Okay, next please. Yeah, but what we are working right now, we predict that in the near future, let's say maybe 5 years or maybe long period or 20 years, we will have water shortage in this area. Even though we already have the plan to increase the water supply, but it will be not enough. So our second plan now is moving forward from the supply side to demand side, and our target for, let's say, the next 5 years is to reduce water demand by 15%. Sorry, that here actually it's 15%. This 15% probably will come from 10% from agriculture and 10 to 15% from domestic supply, and then another 15 or maximum 20% from industry. Let's say that, that is very important, because if we cannot do this, we have to divert more water from the nearby basin, let's say from the Chao Phraya or from Babakong or from the Chantaburi area that is on the eastern side, Chantaburi, the eastern of the EEC, and Babakong and Chao Phraya on the western area. In addition, if we cannot match the supply with the demand, desalination will be another option. We already studied that and we already have done that. So we have no problem. In the next 5 years, if we cannot really reduce water use, probably desalination will be the solution. Okay, next please. Okay, this is move forward to the north and to the northeast of Thailand. That is the tributary of the Mekong. You see the Canadian Moon, Chi, and the northeast Kong basin. This area actually is a little bit sandy loam. For the agriculture is less suitable compared to the central plain and even the east. Next, please. You can see the rainfall and the runoff here. Rainfall is about 1,300 to 1,600 millimeters per year, and the runoff is quite a lot. Actually, you can see from here is a lot of runoff from east basin. It's about 25 billion from the Mekong, and 15 billion from Chi, 25 billion from the Moon. But this area, we have water shortage. And why do we have water shortage? Because of this area is a plateau, and it's not so easy to construct the dam or the reservoir, So next slide, I can show you. Yeah, you can see here. We have water demand and runoff. You can see the demand, the runoff seem to be sufficient, but actually we have water shortage. Just because we cannot construct the reservoir here. Like the moon, we have water shortage. The tree, we also have water shortage. But the Kong maybe a little bit better. We can do some of from the Mekong River, but also a little bit of water shortage. Okay, that's really most part of the north. I didn't talk much detail because it's mostly agriculture. Maybe most of you are more interested in industry, because industry in this area is mostly called, let's say, medium scale, or small scale. Not so much about heavy industry or big industry. Okay, next please. The southern part is the new movement of Thailand for the new industry area. Because from this picture you can see that from number 18 to number 21 and to number 22, let's say, this area is it have a good rainfall, compared to the other part of Thailand, because on the east is the Gulf of Thailand, on the west is Andaman Sea. So it connects to two oceans. One is the Pacific Ocean, the other one is Indian Ocean. That's why we have a lot of rainfall in this area. Next, please. Yeah, you can see here that we have a lot of rainfall, about 2,000 millimeters per year. That's a lot. And water supply is also a lot compared to the other region of Thailand. Okay, next please. Yeah, this show you the demand and then the water supply. You can see that there are not so much shortage at all, because of the water runoff is much higher than the demand. And the actually rainfall period in the southern part of Thailand is much longer than the other part. The other part of Thailand probably rainfall is only 4 months, but in the south rainfall it can be extended up to 6 months, so it will be longer. And that's why in the future we plan to also develop the south to be a little bit of industry and some other area, port or some other thing. Okay, next please. Yeah, and right now like I said earlier, we have construct or initiate a new office called Office of National Water Resources, and we have National Data Bank now. We have on the left, you can see that showing the situation of water resource in Thailand. Actually, we have instant real time of water resource condition in terms of let's say main weather station and water quality. And also on the right, we have let's say now a good prediction of the weather condition in Thailand. That is also on the website. In my conclusion, I would like to say that for Thailand, we try to mitigate. Maybe you have heard about the flood in 2011 that it heavy hit Thailand. The loss is let's say 1 trillion baht, something like that. Sorry that you couldn't see the map. We have right now try to divert water, more directly from the Chao Phraya to the Gulf of Thailand. Not parallel to the Chao Phraya River. So let's say that maybe 5 or 10 years from now, we can complete that. The problem of water, the flood in the Chao Phraya or in the economic area of Thailand can be solved. And we also have some other plan, like enlarge the Chao Phraya River and some of its tributary, and also we enlarge the original drainage system that is in the irrigation system nearby Bangkok, to divert more water directly from the Chao Phraya or from the another tributary to the Gulf of Thailand. I would say that the risk of flood in Thailand have been reduced, and hopefully, if we can complete the plan, as I say, we have no more big risk of flooding. Okay, and in my conclusion, I would say that we still working on the solving the flood, like I say, and also solving the water shortage, through the water supply development of new reservoir or some other thing. But like I say, we need to reduce water use. Chao Phraya eastern area will be the most important area to reduce water use. We also have to increase water use efficiency to make sure that in case of water shortage, in case of a climate change hit, like the drought here, if we have no water shortage, or we have maybe shortage, but it's okay for us to reduce the water use and so on. And the other thing is we are now working on the conjunctive use of surface and groundwater together, to be more effective. We already use it, but it's not really combined together effectively, and we try to combine them more effective. And the one now, we try to have a better prediction of the climate. Let's say 1 month from now, 3 months from now. Right now, we have quite a good prediction of the rainfall, prediction of the weather, so we can see the wet or the dry spell is coming, and what measure should be taken early. Last one, the next one, we try to apply the new technology, into water use reduction and water supply management. Maybe Kunchan will talk to you later on the water use reduction and then 3R technology or whatever, and water supply management on the National Water Resource Office. They try to work a lot on that to combine all together in the country to be one unit that can, share the water management, and also can, let's say, one-stop service, for Thailand in terms of water resources management. And one question that came to me earlier is about the climate change. Actually, we already have the mitigation plan up to now, but in the future, I would say that we are already working on the adaptation part. Like, okay, the rainfall reduction is not the problem. It's not so much in Thailand, but the problem itself is the climate variation. That is really a big problem for Thailand. Like you can see that in the last 10 years, we have 2 big dry spells. The latest one is about two years later, up to this year, we have 2 years in a row dry spell. That is a lot of, it's hard on, agriculture, it's also hard for industry and the other sector. Okay, let me conclude my talk today. Okay, thank you.
Thank you, Dr. Bancha Kwan Yoon, to present us on the water balance assessment and also a bit about national water management guidelines. The audience, if you have any question, please leave your comment or also the question on Q&A button on your lower screen, and we'll have a Q&A session later after the third presentation. Thank you very much, Dr. Bancha, again, to let us know that we have more information, more new information about water resources management in Thailand. We have new national master plan for water resources. We have new act and also new organization for water management just this year. And from the new act, we can see that we finally have 22 river basins in Thailand, which includes 4 major groups: Greater Chao Phraya, East Basin, North and Northeast Basin, and also the South. And from Dr. Bancha's research, they found that in the near future, Thailand will face with the drought problem and also the water deficit. So fortunately, we have the next speakers with us today. He'll talk a bit more about water management with circular economy system. So that's kind of the basic way for solving the problem. Let me introduce the second speaker, Mr. Chuchat Saitin. He's a committee of Water and Environment Institute for Sustainability, the Federation of Thai Industries and Managing Directors of Amata Water Company Limited, with a presentation on water crisis management in accordance with circular economy system. Please welcome Mr. Chuchat.
Thank you, Dr. Donrudi, and good morning, everyone. As my presentation today will be continued from Dr. Bancha a bit, and maybe refer to that detail in Dr. Bancha for overall water management in Thailand. Please go to the next slide. My message to all of you in today is to tell you about the water management by circular economy system, that the water management in circular system is very important and necessary in my point of view. For the focus area is the Eastern Thailand, which have the most the water crisis area that with developing of many projects in here. Secondly, this my message is to share about the water management in circular economy system in the industrial park in the area of the East Basin. The third is may you understand the solution of the East Basin drought crisis in overall management, that collaboration between the private sector and the government to overcome the crisis in the future. That is all my message, and that is a focus on the Eastern area, Eastern Basin. Next. I'm talking about the East Basin. You can see that in the Thailand, the increasing demand in in my view, we have many projects developed by the government that promoted the industry, the tourists, to rise the income level of Thailand from the middle income country to high income country. This project is including the developing the Suvarnabhumi Airport, Utapao Airport, to increase the of the capacity. And there are two deep sea port in this area. That is the Lam Chabang deep sea port and Mataput deep sea port, with the high-speed rail connecting Don Mueang International Airport and Utapao Suvarnabhumi Airport together. That all these projects will result to increasing in the population demand in the water consumption in this area in the future. All in nothing. This is in my view, why the water demand in this basin will be increased a lot in the near future. Please go to the next slide. Talking in terms of the supply side, I'm talking about the annual rainfall and cycle of drought crisis in Thailand. I have started work with the Amata Corporation to develop the industrial park since the year 2001. Actually, this industrial park start development from the 10 years before I joined this company. But in the year 2005, after the first drought crisis happened when I come to join this company, it's really bad because of in the middle of the year, the stock of water in the storage become have the stock the water in the storage only around 10 or 20%. It's almost run dry, but that year the rain forecast to come on another 4 or 5 months in the September. So that is a very, very severe crisis in the 2005. And you see in the chart, this is the record from the meteorology station in Chonburi in the focus area is show that every 4 or 5 years, the minimum rainfall will come back as a cycle of drought crisis in this area. So that is make me have a point of view that we have to overcome this crisis in terms of long-term prevention. So we have to set the strategy to be recover all the damage that impact from drought crisis in the future. So that is become to use as a strategic movement of the company or the development of industry in this area. So please go to the next slide. So we start with the analyze the rainfall pattern in this area. As we get the record from the meteorology station in Chile, we do the monthly rainfall pattern. You can see in this chart. This is the whole monthly rainfall pattern in the basin, the eastern basin. When we analyze and to see the monthly rainfall pattern change in this area, you can see in this the top, this chart is showing the pattern of monthly rainfall in the year before 2000, and the lower one is showing the pattern of monthly rainfall in the year after the year 2000. So the remarkable change that we can see is that before the year 2000, we built the reservoir in this area around 3 a year. But after, due to the climate change, we can fill up the reservoir only in 1 year. So the meaning is that we can utilize our reservoir in 1/3 of the year before 2000 only, because in the year before we can fill the reservoir 3 times a year, fill up it full. That is my my point. Next. So this is the I just give you the what happened in the year 2000. That is, we have a drought crisis again because of in the left side this chart. So the green one is showing the stock of water in the whole reservoir in the eastern part. At the end of rainy season, it's very low, but at that time, compared to the year 2000, this is 2005. And the red one is in the year 2019. The difference is in the year 2005, it have a drought crisis, but at that time, the demand is less than half of the year 2019. Comparing the number of the customer or the factory in Amata, at that time, it's say around 500 factory in our industrial park. But in today, we have the more than 1,100 factory in our industrial park. So that means the demand is increased more than twice in the industrial park. But anyhow, the water in the storage in this area still less than the 50% of the capacity of the reservoir because of the minimum rainfall in this year. So that is resolved in the crisis in the year 2020. Please go to the next slide. You can see when we started the amount of water in the storage can be used in the year 2020. from the beginning of the year, we can see that if we use the consume the water as we did in normal, all the reservoir will die in the mid of May or the end of May. How we can do and can manage the industry? This is I talking about the whole basin. Now, because it's different for the Amata, they have a water security system that I will show you in the next content. Now, the whole bin we will get the reservoir and die around end of May, but we predict that the new rain will come on the around August or September. That how to make this period. So the way we did in the year 2020 in the beginning of the year is reduce the pumping water from the all reservoir, that reduce the water supply to all industry around 10 to 20%. That is the way we manage the crisis in the year 2000. So this is I just understanding that how serious of the water crisis that impact to industry. Okay, next slide. So in terms of the industrial sector, our goal is there should not any industry, because water shortage impact, it have the impact as the whole year, not the same as the power or whatever, but we can supply with alternative system like gasoline or whatever. But the water, the season is come back in another year, so the damage will continue up to the industry. So the goal of the strategy choose aim at the no water short for industry anymore. So please go to the next slide. So that is why I'm sharing with you about the water crisis management in circular economy system at Amata Industrial Estate Land, because of my point of view that I present you already, that it impacts so much to the industry in terms of 360 days of the cycle of rain that coming, and it happened every 4 to 5 years. Okay, next slide. Amata actually developed the industrial park in America, South Pacific, in Thailand, and in Vietnam. That focus that have we developed the industrial park. So I'm focused in the industrial park in Thailand, which located in the eastern basin, the East Basin. So this is the study of the water management in circular economy in Thailand. Next slide. So this is the water security management strategy of this industrial park, that industrial park. The first strategy is develop water resource development. Wherever we develop the park, we have to develop the water resource management ourselves to be the alternative source that the more security, more investor in this. This is the first strategy we go. Second is as Dr. Bancha had told in the previous presentation, the way to have the more security in the eastern part, but with driving the water in demand with the many projects from the government. So we have to be survived with the increasing water use efficiency in the industrial park. That the water I will explain in next. So next. The first strategy, water resource development plan. In the water resource development plan, we study the kind of water source that we can develop for industry. The first one is surface water that with the lowest cost of water uses. Second is groundwater. The groundwater is very limited in quantity of groundwater in the eastern Thailand. It just studied that only big basin in the Ban Khai district that not development yet, but in the study there is a big basin in there. Third is proven to increase the user efficiency. That we are using and in this time. The water safety system doing solution system is investigation and study of the government sector to do the desalination system, seawater desalination, to make the highest security for all sectors in the eastern of Thailand. Next. In Lamata, the transition water management to circular economy system to increase water usage efficiency. So in the past, before we face a drought crisis, in general, all industrial park will manage water as a linear assumption. The system they draw water from water resource, produce, treat, and pass to the customer. Then the customer in the park will discharge to the central collection system. Wastewater will go to the central wastewater treatment system and treat to comply the standard of the water to the public tenant. The whole in Thailand. And besides this is where the criteria we were thinking about how to high security of water management to the all investors. Then we change the system into the circular economy system that we collect the all treated wastewater to the wastewater reclamation system at the first osmosis membrane system. And this system will produce the water back to the industrial park again. That we next slide. We studied that by the record over the statistic of the 10 years, we found that in Thailand, two industrial estates, one is actually the all wastewater that collect by the central collecting system. We found that the amount of wastewater is 40 to 60% in Chonburi, and the Amata Industrial Estate in Rayong, we found that it's almost the same. It's 44 to 61%. This is the kind of industry is the automotive, electronic, and the sum of the like the coating or something. That is this amount of the water that discharged from the factory is almost average is 50%. That to go to the recycling system. Okay, next. In the wastewater management system, we have this in the beginning because we in industrial park it will be easy to manage all the factory because all factory that invest in the industrial park have the same system. They have to design the factory that arrange the system to separate the rainwater from the usage water that we call wastewater. All wastewater will be designed to collect and discharge only one point to the central water system. This is the design and stuff will be controlled by Industrial Authority, Estate Authority of Thailand, that we call IEAT. So the design has to be proved to this before getting the license to operate. When operate, the Amata will have a system to do a random sampling, check the quality discharge before they discharge to the central collection system. This is to be ensured that all the wastewater will be controlled to meet the requirement, the central wastewater treatment system. We design for the whole that this to handle the quality and treat until it meet the standard of water discharge to the public canal. And then we recycle this all water to the cooling system in power plant, to the green area in the park. The rest go to the RO reclamation system and supply back to the industrial use for the production. Okay, slide. This is the program I'm showing you in model that is the resource management. We draw water from natural resource, and we also have the resource in the Amata to keep the water for the whole year. We have the forecast system to see what will happen in the next year. This is a El Niño, La Niña, because our country is in the middle of the Pacific Ocean with the ENSO phenomena that we call the El Niño and La Niña phenomena. And also we have the influence from the Indian Ocean as an Indian Ocean dipole phenomena, that we have a positive dipole, negative dipole, and neutral. So it's the same. We have to see both sides of the country with the two phenomena together to predict what will happen in the next year and manage our resource before at the end of the rainy season. Now, then this part is the increasing capacity, the efficiency of water use, the reuse by integrated wastewater from the central wastewater system into the green area power, cooling system in power plant, and then go to the reverse osmosis reclamation system and supply the high quality to the industrial use. This is the system that we plan to do. And then the next, please go to the next slide. This is the sample of the one station of wastewater liquefaction plant in Amata Industrial Estate. This figure is the whole system. The water goes to the wastewater treatment system. The wastewater is the treatment system go to the final state is the sludge dewatering system to remove the sludge from treated water, wastewater. And all treated wastewater is pumping to the holding pond before recycle, use clean air and power to cooling system. The water is this second, to the treated water that we use for the let's go to the RO reclamation system, that the quality of water is very clean, better than the PWA standard, because normally PWA standard have the turbidity control at 4, but however the water that feed into the RO membrane have to be less than one unit turbidity, so it's much better than the standard of PWA. So in terms of the cost, we also reduce the cost of recycling system, because the recycling system, the mainly cost is 30% is from the electricity, because the system needs the high consume of electricity. They build the solar panel as a rooftop and floating solar in the project to reduce the cost of it. And also we get the reduce the greenhouse gas emission and all the emission from the same. So that is two target of the managed water management in terms of the reduced global warming as well. We also have the learning center to improve or to increase the public awareness about the water conservation or water management, water security. Now, we have set up the learning center for the public or any country, anyone who would see and find how we manage the water security in our park. This is just showing the quality of permeate water from the reverse osmosis membrane. So far, we reduced consumption from the natural resource 40% by the system. Now, that is my message. Okay, next. This chart is just explain you more about before we have the recycling or reclamation system, the water at the beginning of the year we stock in the reservoir can use maybe 10 months. So after we did the recycling system, the same amount of water can extend to 10 months, that 40% of the water what we have the same amount, but we can use for longer period. This is water security system. Another maybe explain in another way is that we reduce water consumption 40% from our limited source. Okay, next. So far in Amata Industrial Estate has the 5 water leaking with the 10 million cubic meter per year and 37% of water consumption for industrial use, but another a few percent is for recycling to clean air and cooling system. We will have 40% saving. Okay, next. This is the model I just present to the subcommittee of the House of Representatives for water crisis management in the eastern region of Thailand to find the solution of water crisis in the east coast of Thailand. As Dr. Bancha said that we need a collaboration between the private sector, government sector, and all sector, and that including agriculture, private domestic consumption, industry, tourism, or whatever, they have to be aware about the water crisis, its cycle, and how we can overcome that crisis. Water usage efficiency improvement is one key success factor of the solution for water crisis. Because we're going to see water desalination with high cost, actually consume around 4 house electricity. That's 4 times less water. Because recycling water, it needs around 0.8 to 1 kilowatt hour per cubic meter of recycling water. But in seawater desalination, as I have the experience to visit the Israel, Singapore, Australia, they do seawater desalination. Its average is around 4 kilowatt hour per cubic meter of the desalinated water. So we have to improve the water usage efficiency before we go to the seawater desalination system. But anyhow, we still need the seawater desalination to get the to overcome the in the future. That is the best solution, the most water security management system. Okay, next. I think I can't, it's coming to the last slide for mine. This is I just want to tell you that we have the highest security system by the government, that the government have the official of water resource, National Water Resource Agency to manage the overall policy of water management in Thailand. And we also have the subcommittee to find how to do the seawater desalination system in Thailand for the highest water security in the eastern part of Thailand, to support the all project that the government done as the developing seaport, developing and increasing the capacity of the international airport, the high-speed train, the airport, all is driving the demand in this. But we have to make sure to the mitigation plan to overcome the crisis by improving the efficiency of water usage in all sectors. Agriculture, we have to reduce the losses on the distribution system. Industry, we have to do the 3R system and the circular economy to reduce the water consumption. The private sector and sector have to control the demand of wastewater to the water resource that can be contaminated source of water and reduce the supply capacity. So the whole is the final key for success factor is collaboration and awareness of the public awareness about the crisis in this region of country. And the target of the country is to raising the country income level from the median income country to the high level income country. This is our country goal for the water management. So that is my message for this time. Thank you.
Thank you very much, Mr. Chuchat Saitin, for the presentation on water crisis management in accordance with circular economy system. So the audiences can see that mostly Mr. Chuchat concerned a lot about the water crisis in Thailand and especially in the industry. As we have the increasing water demand but low water supply, so the circular economy system is very important. The goal of using the circular economy system from his presentation is to increase water use efficiency by transition of using linear consumption to the circular economy system. His interest, Mr. Chucha's interest is starting from a drought problem with the frequency of every 4 to 5 years for the past 45 years ago. So he tried a lot to apply the circular economy system. The audiences can also see the good example of using the water security management strategies in Amata Industrial Estate in Thailand, which is mostly about the wastewater recycling. Mr. Chuchas also showed that the water is saving for like 40% of total consumption of the system. And he also mentioned another alternative source of water for industry. Another one is the seawater desalination technology. And fortunately, we have the next speaker talk about the seawater desalination. But before moving to the next speaker, may I thanks to Mr. Chuchat again. Thank you very much. The next presenter, I have to inform that he cannot make it here today, but he have sent out already the presentation. But if the audience have any question, you can type on the Q&A button on your bottom screen, and later we'll send him the questions and answer you later through the email. Let's move to the next speaker, Mr. Sid Volbert. He's the CEO of the Elemental Water Makers with a presentation on alternative ways of providing water source, seawater desalination technology.
Everybody, welcome to my presentation. Before I start telling you a little bit more about elemental water makers and solar desalination, I would like to start with sharing a bit of a personal journey that brought me here. I'm not sure if any one of you has ever been to Madagascar. Perhaps people have seen the animated movie Madagascar. It's actually not really resembling the truth, because Madagascar is one of the 10 least developed countries in the world. Before I start telling you a little bit more about 10 years ago on a surf trip, solar desalination, I was making my way there from the capital of Antananarivo to the coastal city of Tudiar. I came across these boys. And these boys were carrying water with vehicles they built themselves to fetch water for their families. And I tasted and I tested this water, and I found out this water doesn't meet our drinking water standards. It's salty, it's unsafe for drinking. But for these boys and for their families, they have no other choice. This is the only water they have. So they spend hours every day collecting unsafe waters, reducing their life expectancies, and also limiting their chances for development. A couple of hours later, I found myself drifting on my surfboard under the abundance of the sun in this vast ocean. And that's where I realized that we should use these elements of the sea and sun to overcome water scarcity. And that's really the origination of the venture called Elemental Water Makers. It was founded by me and a good friend of mine in 2012. So that's almost 10 years ago. And Elemental Water Makers turns seawater into drinking water using solar energy. And I'm going to spend today with you to tell you a little bit more about this process, how it works, and what the costs are, and what the standard issues are. But before we do that, I think it's also good to first zoom in a little bit at the problem at hand. We're a Dutch company, so we're based in the Netherlands, in Europe, but we are globally exporting, and we're currently active in around 20 countries. So I think there's a good match here also in the Asian region. Because when we look at water supplies these days, it's becoming less and less obvious that there's a reliable access to fresh water. There's already 4 billion people that face water scarcity today. And this number is only a growing of nature. And to me, access to water is the biggest challenge for humanity in the 21st century. They don't call it the oil of the 21st century for nothing. And it has to do with the increase of population, of course, we have more people that want more water. They drink more water, but it's also in the food that we consume. So basically food is 70% of our water footprint. To grow the coffee beans that we consume in our coffees, or to grow the wheat that is eaten by the cow to be turned into meat. So it's not only the water we consume, but it's also the food we eat, the clothes we wear, the energy we produce, and all the products we have. Well, currently, we use around 4 times the natural water cycle to provide all the people with enough water. So that means that all our natural water reserves are highly under pressure. Aquifers are dropping and salinizing, and wetlands are quickly disappearing. And that's a big issue. And last but not least, there's also climate change that changes weather patterns. So we have longer droughts, and we have very strong rainfall in a short period of time, leaving the earth unable to capture this water. And these three trends together make water one of the biggest challenges for the next decades. But of course, this doesn't portray itself directly on people. But when you think about how are people involved in this global phenomena, it's often these kind of news headlines that make it evident that these days it's not a question anymore if there's going to be a drought in the dry season, but it's really who's next. So there's always California, there's the Horn of Africa, there's the south of Europe, Taiwan was been hit recently, there's Australia, there's a lot of regions in Asia that are very pressurized when it comes to the water supplies. But fortunately for us, if we look at the water availability, 70% of the earth is covered by water. From all this water, only 3% is fresh water. Which means 97% of all the water is salt seawater. So looking at these numbers, we believe that the key to extra water resources partly lies into the sea. And this brings us to desalination. And desalination, it's nothing new. It's been done for decades, but it's considered as expensive because it's a very energy intensive process. And when energy is expensive, the water automatically becomes expensive. It's a process that has the perception of being fossil fuel driven, a bit dirty, because when we use fossil fuels for desalination, this also means we are accelerating water scarcity by increasing droughts. So we find ourselves in a vicious circle. And last but not least, it's also a process that's considered to be very complex, only feasible at large-scale factories in, for example, the Middle East, not being easy to maintain by smaller projects or local communities. And these really are the 3 challenges that we as an organization took, and we asked ourselves, how can we get fresh water today without limiting tomorrow? So this is the origin, this is the philosophy, these are the grounds of our organization. And what we did is we developed new desalination technology that makes turning seawater into fresh water much more efficient. So when you normally do desalination, and when desalination is mentioned, we talk about reverse osmosis, which is the most energy efficient membrane-based process. It works by putting seawater under a high pressure, 50 to 60 bars, and then having fresh water being generated as the H2O molecules travel through the membrane. For this process, conventionally and traditionally, you need around 10 kilowatt hour for a cubic meter. And that's a lot of energy, of course. What we did is we reuse the salt water flow. So there is seawater coming in the membrane, there's clean water coming out, but there's also a saltier water flow that is still present, that is still pressurized, that also goes out and goes back into the sea. This is called the brine flow. And this brine flow still contains the 50 or the 60 bars of pressure that you originally put on the membrane. And this energy we reuse using an energy recovery device, abbreviated as ERD in this picture. And by doing so, we are able to use 70% less energy. So we reuse the saltier water flow, we take its pressure, we provide it to the pump, kind of like a turbocharger. And this allows us to use only 3 kilowatt hours for a cubic meter of water. So that's 70% less energy. The second step we do is we integrate this water treatment process into the fluctuation nature of renewable energy such as solar energy. So we are able to use the sun with a small battery bank to power this desalination process in off-grid locations. And of course, due to this innovation, we also need 70% less panels. So that's what makes a major breakthrough, which makes freshwater at coastal locations possible for everybody these days. So what we offer with our solar desalination technologies, it's first and foremost, it's water at lower expenditure. So of course, when you have to transport water now, it can be very expensive. So what we do is we generate water on site at lower expenses. But besides that, we also make sure it's produced in a sustainable fashion using solar energy. Reliability is very important because you cannot operate either a resort or an industry or have a community or a private property without water. So reliability is of utmost importance. And it has to be easy to maintain using remote monitoring, using durable components, so really high grade, not RVS steel because it erodes away within a year, but really titanium pumps or 904L, robust materials, durable components, automation and remote monitoring together are the key for a long-term and sustainable project that saves on the water expenses. And when we look at our current global footprint of projects, you can see here a little map. And you see that most of the projects we do are in Africa and in the Caribbean region, but there's also a large amount of projects that are being developed, for example, in the Philippines, but also in Indonesia. We also see a lot of water demand on the islands in Vietnam and Thailand. So we think there's really a big opportunity here that we are happy to jump onto with the right local partners, of course. When we dive a little bit deeper into the technology, we have 3 types of solutions that we can deploy that can generate between 3,000 and 500,000 liters of water per day. So 300 to 500 cubic meters of water per day. That's the sweet spot that our organization operates in. We don't do larger plants and we only do seawater desalination, so only coastal applications. And for these kind of numbers, you talk about roughly $1 to $2 for a cubic meter of potable generated drinking water. So that's the range of investments you have to think about for all of these solutions. So we have 3 different solutions that we deploy, and let's zoom into them quickly. So they all are in water scarce coastal regions, and of course, the payback is shorter if the energy prices are higher. So the first solution is only the water treatment part, so the efficient desalination range we have. And here we deploy containerized or skid-built units. On the picture you see, for example, a project of 90,000 liters per day, the desalination device and the remote monitoring. And they only use 2.7 kilowatt hour per cubic meter. And this uses the existing electricity supply of the client. So if there's a resort or a community or a private property that already has reliable and affordable electricity, these are the units we can deploy, either skid built or, for example, containerized. We can do 300 cubic meters per day in a 40-foot container. And compared, looking at the economics compared to conventional desalination, which of course has the perception of being expensive, here you see 2 lines of the investment required and also over time. And you see that the conventional desalination systems, they have a little bit lower investment required, but because of the energy required, the operational expenses are quite high. And when you look at our system, the light blue line, you see that the operational expenses are much lower, leading to a short payback and strong savings over time. And you see that represented as well in the water tariff. If you calculate these numbers over 15 years, you see that the amount of electricity for the traditional systems is much higher. So you're looking at $4 per cubic meter. But here with our system, we're below $2 per cubic meter. And this is for a system of 10 cubic meters per day. So this is one of our smallest systems. So that would be suitable, for example, for a small boutique resort or a small community of a couple of hundred people. And here you see another project. This is a containerized solution. We deployed this year in Curacao for a big resort. And this, for example, makes 90,000 liters per day for the guests. And it saves the client over 60% compared to their previous water supplier. So that's, of course, reliability, sustainability, and then also savings all at once. So that's a great project. When we transfer to locations that don't have a reliable electricity supply, this is the solution then we can deploy. And this is really an off-grid system. It's called the elemental water source. It's a plug and play containerized unit. So everything that you see on top of the container, so the solar panels, freshwater tanks, the frame, it all fits inside the container. So it really comes plug and play, ready to deploy. And I brought a little video with me that shows you a little bit more about this process. So let's take a look at this video.
Water is the source of all life. However, fresh water is getting more precious by the day. Many islands and coastal areas are facing water scarcity. How do we ensure sustainable access to clean water? At these coastal locations, there are two elements abundant. The sun shines over the vast ocean. This is where the elemental water source makes the difference. It offers an easy-to-deploy water solution for any off-grid location. The source turns seawater into potable water using only solar energy. It's the world's first efficient solar desalination solution suitable for quick deployment. One elemental water source provides sufficient water for off-grid users, such as communities, resorts, industries, or private properties. Due to rapid deployment and ease of operation, it's also the perfect water source for emergency response and disaster relief. It uses 3 times less energy than traditional desalination by unique energy recovery technology. This ensures that the water can be enjoyed at an affordable rate. Tap into the elemental water source and ensure clean water for generations to come. Join us in solving freshwater scarcity using only the sea, sun, earth, and wind.
So this elemental water source is containerized off-grid solutions. They find suitable use in off-grid locations, such as for a community water kiosk, but also for temporary applications like in emergency response situations after a disaster or a cyclone has hit. It is possible to quickly deploy these units, but of course for other off-grid applications such as private properties or resorts or industries or irrigation, this is also a very suitable solution, as long as there's access to the sea, of course. As I mentioned, they come pre-built, pre-mounted in a small container. Of course, it really depends on the size of the water demand for the clients. So we can do small-scale systems like 3,000, 5,000 liters per day. They come in this 8-foot container. But of course, as the water demand increases to 10, 20, or 40,000 liters per day, also the size of the container increases. So all we need to know for the location is really how much water do they need and what is their location. And this allows us to really quote a custom project, design a custom project, taking into account water quality issue, parameters, the usage of the water, but also the local solar radiation. So this produces water, but this can also be extended with additional power for our energy appliances, smart water taps for distribution, water storage we can implement, and also Wi-Fi. So this is a very nice application for off-grid locations. And as I mentioned, it's mostly for places that are now receiving trucked water, for example, through water trucks or through boats, or places whereby people are carrying jerry cans or jugs or water bottles, actually. Once you start transporting water, it becomes very expensive. So if you are at a coastal location that is transporting water, I recommend to contact us to see if that we can make these kind of cost-benefit calculations for you, because I'm sure that the payback is short, as you can see here, and the savings are significant, besides the reliability and independence of it. As I mentioned, we already do some projects in the region. For example, in the Philippines, we work together with a local partner, Next Level Water, and with them we are deploying water kiosks. And in these water kiosks, people are employed to operate and maintain the system, and thereby they sell the water, distribute the water, and by doing so, they can earn their income. So there's also economic growth that can come with such a technical solution. So here you see the model, the water kiosk model. It's also suitable for impact investments, also by bundling more projects for more islands. this makes project financing also possible. So these are models that we are also very eager to explore. And the last solution that we do is a gravity-based solution. So instead of using a battery for energy storage, we use potential energy. So we needed 50-60 bars for seawater desalination. So you can imagine if you pump seawater to a vessel of 500 meters height, that this provides sufficient elevation for the process. And then if we use a solar pump to fill up the seawater tank, then we can constantly desalinate water. And what we did here is that we also added the energy recovery part that limited the amount of elevation with 80%. So if there's a hilly coastal region, we can do with 90 meters, we can constantly turn seawater into drinking water while only using fluctuating energy from the sun. So this is, for example, only possible at places with that natural elevation, of course. And this is, for example, a project we did in the British Virgin Islands that generates around 12,000 liters per day. And the nice part here is that there's no energy conversion losses, so that it's really suitable and efficient. So you see here on the graphs that using only the solar energy during the day, sufficient water is pumped up towards the elevated water storage tank. And then by constantly making water with the desalination process, the reverse osmosis, it is possible to provide constant water 24/7 while only using fluctuating solar energy. And that's kind of cool, but as I mentioned, you do need the elevation in the natural surroundings. So yeah, also the economics here are strong. I think it's good to mention that because desalination always has some negative aspects, it's always about the brine. It's good to mention that when you talk about brine, it's basically the same water as you took from the sea, but then in a more concentrated version. And what we do to overcome issues with the brine is that we don't use any chemicals. I'm sorry about that. With the brine is that we run on a low recovery ratio, so that the concentration difference between the brine and the original seawater is limited. And we can do that because the energy recovery device has efficiency over 99%. So the brine is of lower concentration, making it easier to return to the sea, but also it doesn't consist of any chemicals. We don't use chemicals to clean the membranes. There's automated fresh flush cycles involved when standing still. So no chemicals are being returned. It's just slightly saltier seawater that goes back into the ocean. And of course, as we already said, the operation and maintenance, we train local people, local staff to operate and maintain. We work together with local partners to provide support. And then we have the remote monitoring, the durability and the automation integrated into the system. The last solution we recently deployed is really for emergency response. It's called the elemental water response. So imagine there's a situation that the water supply has been affected by a major event. Before, people had to fly or truck or transport jugs of water, but what we developed is really portable solar desalination devices. You can see them here. They weigh around 30-40 kilos. They can be put in airplanes, so they can be ready on strategic locations. And one of these cases has the solar energy part, so the foldable solar panels. The other case has the water treatment. And just by putting the hose in the seawater and folding out these solar panels, you're able to produce around 50 liters per hour. And this is very suitable when it comes to first phase emergency response. So we are also supplying these to local governments. So what we say, water for all, we do a lot of work for resorts and commercial properties like properties and industries, but also together with NGOs for remote communities, together with local governments for remote communities that don't have access to safe water, SDG 6. So we are interested to hear from you, what market you would like to work on. I think it's also important to say that we started this project really in Madagascar with the inspiration, and we also started a foundation that brings back water to Madagascar. Madagascar is currently in a very severe drought. A lot of people are suffering, but we have a foundation that also donates, that raises projects and donates it to the local people there. This is a picture we did 2 years ago for 3,000 people for the water supply. And we're going to do much more of these kinds. So we are very proud to work on those people. This is a picture with Mohammed bin Rashid Al Maktoum, the Emir of Dubai, who awarded us out of 138 companies as the first prize winner when it comes to solar desalination technology. So from the tribal people in Madagascar to the Emir in Dubai, we all need water. So let's work together on that to solve freshwater scarcity using only the sea, sun, earth, and wind. I will be available for questions. And I would like to thank you for your interest and your time. And I hope to hear from you. You can contact me using sit@elementalwatermakers.com or check out our website, elementalwatermakers.com. Thank you and see you soon.
So from Mr. Sid Philibrect, in the presentation of alternative ways of providing water source, seawater desalination technology. Again, I would like to emphasize that if the audiences need to leave any question or comment to Mr. Sid, please leave it on the Q&A button with your email address. We'll send the question to Mr. Sid, and here send you later the answer offline. From his presentation, you can see that desalination of seawater in the past used to be the energy intensive and expensive. Elemental water makers developed more efficient desalination solutions for applications that can be combined with renewable energy. Their latest invention as a response to COVID-19 is a plug-and-play containerized unit that can be deployed quickly to ensure affordable water on site. So if you are interested in it, let's join them in solving freshwater scarcity using only the sea, sun, earth, and wind. As now we are coming to the last session of the presentation today, we can have like 30 minutes for Q&A. And as the topics are really interesting today, so we have lots of questions. And thank you very much again for all questions. But I would say apologize to everyone that I can have only some questions, like 3 or 4 questions for each speaker. But we will try. If we cannot answer all submitted questions during this period, we'll be sure to share the speaker all of the questions that we cannot reply today. Let's start with the question to Dr. Bancha. May I ask this question? Since 3 years, I am highlighting the importance of rainwater reservoirs. Is there any investments from the government or public seriously? Since from November last year to May this year, it is really dry. Clean water resources are limited. Please, Dr. Bancha. Dr. Bancha, could you please turn on your microphone? Thank you.
Yeah. Okay.
Thank you.
Yeah. You know that the problem of the new reservoir development in Thailand is the topography. You know, because of the all suitable location mostly have been developed. You know, so the location that available now today is mostly environmental effects in terms of its you know, let's say classified as a reserve national forest. You know, let's say the base class, or if also there's a problem of the cost. You know, the cost per unit of water now today is much higher. You know, let's say Bhumibol, that is the first dam. You know, the cost is only probably can recover within, let's say, 5 years of construction. You know, but the new reservoir now today, most of them cannot even recover themselves by the construction because the cost per unit of water is so high. So the RID or Royal Irrigation Department still develop new reservoir, but the increasing rate is much lower from the last decade. I mean, this decade is much lower because of the new location that is suitable is much less. The other thing that the government and the public try is just try to help themselves by making, you know, like a pond, you know, rain harvesting and those type of things. That I think that is really the solution for people in the area that we have a, you know, really dry or drought, and you have some good location to construct the ponds. You know, my recommendation is the pond have to be at least 5 meter depth and the location has to be on the lower area, you know, or some other thing like, and you have to estimate that the harvest of the rainfall is good enough, you know, to match your demand. That is quite very brief on this. Okay, and also the other thing is we try to promote the technology for water reduction. Let's say that for rice, you know, now we promote the, let's say, wet and dry technique, the technique to use less water. Maybe I didn't have time, you know, to explain you what is wet and dry technique, but I have do a lot of experiment on it on the last 10 years, and even I have done it. And we can reduce water use by 30% by using wet and dry technique. Not let the particle, let's say, covered by the water all the time. Maybe only half of the time. The other time, let it dry out, and you know the seepage is reduced, the evaporation is reduced, the water use is reduced. We can also have another measure, you know, for upland crop, you know, like maize or cassava. You know, that is some other technology that can be applied. Thank you.
Thank you for the answer, Dr. Bancha. Let's move to Mr. Chuchat. The question number 1 is there any plan for promoting the rainwater reservoirs within the factories, as you are the main developer of Amata? Any plan for existing industrial estates?
Oh, sorry, please. Sorry, it's really pure. You hear? Hello.
Sorry, maybe the connection is kind of low. May I read the question again here? Is there any plan for promoting the rainwater reservoirs within the factories, as you are the main developer of Amata? Is there any plan for existing industrial estates?
Actually, by the regulation for developing the factory or the industrial park, we recommend all factory to have its own storage at least 1 day for the reach of the water. And in the accident, even the system accident or whatever, they should have. But the overall industrial park have to be controlled in the beginning of the development of industry. Now the industrial estate can be managed for the whole park to secure the system that the investment can be secure, can be overcome the crisis. That is the management system. But decide to invest the resource or the pond is depend on the development, the development that they may invest for the different kind of rich level of rich. But for the Amata, I show you it. The risk management for water shortage is the top issue, the top risk management level of the Amata group, that they use the highest security for the water crisis management. So we hope that, as Dr. Bancha said, water security will managed by the overall policy is come from Office of National Water Resource, and that will have a policy. We have a basin committee to manage the water resource in the basin, and we also have the Water Resource Act 2018 that will implement in the is now in the last 2 years will be execute the full of the law in the next year, so that will help all the industrial sector, all the water usage sector to improve their efficiency in water use. And also the OW RN, Office of National Water Resource, have the duty to find the solution of the water scarcity by doing seawater desalination system. So the system have, but how to implement, make the implement. That's why I said the public awareness is very, very important. They have to be aware and alert about the water crisis in the next year, in the future, how seriously impact the sector if we don't have. That is my answer.
Thank you, Mr. Chuchat. Then I'll be moving to Dr. Bancha again. The second question is, what were the main reasons and expected benefits of reclassifying the main water basin in Thailand recently?
Yeah, let's say, I have to explain you first. The 35 basin is started about 30 years ago. You know, that the harm is like, let's say, a rapid work, you know, that have been done, classified, just because we have initiated to announce the river basin committee and management water as a basin. So that is a quick work by the Office of National Economics and Development. You know, actually it's not done by the, you know, the engineer or, you know, the geography. It's done by actually economists, something like that, you know, at that time. And many basins, they are not suitable, and it creates a conflict in the long run. Let's say the place nearby Kuchuchatberg, Bang Pakong and Pachimuri, actually the same basin. It should be the same basin in affecting the start, but it's separate to upstream basin and downstream basin, and they have conflict for the last 30 years. You know, to blame on each other, but right now they are the same basin, so that conflict has been resolved. You know, and the other one is on the north, that, you know, that is actually they combine the northern basin of Mekong with the northeastern Mekong to be the same committee. How come? Different region, the same basin. You know, so now they are separate because of it. It makes sense. You know, and there's one in the south. The southern part is a little bit funny, you know. If you have a look at the southern part, you know, it's separated into the basin that have been, let's say, 3 pieces combined together. One piece here, another piece there, combined to one basin. It doesn't make sense. That by we, you know, renew it and make it more easier for the management and people to have a dialogue and talk, you know, because that one. I mean, we try to change that in the last 10 years, but, you know, the law haven't come, you know, now the new laws come, and we can really have a new basin. That's why we actually reorganize the basin. Okay.
Thank you, Ajahn Bancha. I found one more question, which is, I think, related to that question. Question number 6, I wonder how the trans-boundary water issues are handled.
Yeah, in the past, the trans-boundary is handled by the National Water Committee only, you know, by policy. But nowadays it cannot, you know. It has to be by kind of dialogue, you know, between River Basin Committee, you know, but it has to be some kind of compensation. It has to be some kind of commitment. It has to be some kind of agreement, those kind of things. That it has been written, and the detail of the, let's say, the regulation have to be written down this year or next year on this dialogue. And the quota, now there is no quota, you know, for Bangkok, how much water we can use from the Chao Phraya is no quota, but in the future we will be some kind of quota for agriculture, for you know, for industry, and for, you know, other sector. And will be agreement between basin that combine together, and also agreement between basin, like we today we divert water from Mekong to Tajin and to Bangkok. And in the future, it has to be some agreement and some compensation or some other kind of thing. I think this kind of mechanism, it will be developed very soon, you know. But in the past, it's only by policy. Okay.
Okay, one more question, Dr. Pancha. Kind of keep continuing on that question. Question number 5, as you mentioned something about the users, I really want you to answer this one. To reduce water use is a good idea, but I was wondering how to practically implement to be successful in practice. Reducing water use by 15%, as you mentioned, may not seem very much, but in reality, how to convince the user, for example, the one in the agriculture sector, to make them realize that direct benefit to be gained for water use reduction?
Yeah, actually, this is not really target that it come from nowhere. It come from research. We already done the work and we know it can be done. I give you an example. For durian in Chanthaburi, Rayong, that is eastern. We actually install some device into the xylem of the tree and measure the water use and recommend the farmer how much water should be used. For easy answer. In the past, for the big durian tree, they use about 300 liters, per tree. And from our research, we found that it needs only 150 liters per day for the big durian tree that maybe 10 years age. And many farmers cooperate with us and reduce to something like 150 liters or 200 liters or 200 liters. And that is about already 30% reduction of water use, but that is only for durian. But for rice, you see, like I mentioned earlier, for wet and dry technique, we have done this in the last 10 years, and it's successful in many areas. But the only thing that is the constraint is the water management have to be good in the area. The farmer have to be in a group, and they really act as a group. Not just one take water at the time of it should be the quota of the other, and that one the system will collapse. That kind of thing needs some more cooperation. We try to work that in the near future. For domestic water supply, we already work with the provincial water authority and Pattaya and some other city there in the last couple of years, and we also survey the confidence of people on water, reuse or water treatment, and people agree that okay, if we have the water treatment in Pattaya or big city around there, or even Bangkok, and we can use that water back to be the raw water for industry, even for the raw water or water supply, and we have done that work. That actually our work right now is continuing on that. I'm working on the called Spearhead, Spearhead program, research program. That is the 2-3 year program, and right now we work on the. Relate to the next question is actually on the incentive, the 7th question on the incentive, or how incentive. Right now we are working on the incentive. What do the industry need as the incentive for them to invest in water saving? I mean, it have to be a BOI incentive, or it have to be tax incentive, or it have to be some other means, or reduction in terms of import of equipment or some other thing. We are working on that. I think by the mid of next year, we will have answer for that. We even initiate the organization that in the future, do we need some other organization for the EEC particularly to overall water management? Right now we don't have one, but in future we try. So that we answer many questions there. Okay. Yeah.
Okay, so as Dr. Pancha mentioned about the water treatment, I'll be switching to Mr. Chuchat with the question number 7. There's a question regarding the efficiency of the water circular system. Is all the wastewater reused in this factory? If not, how many percentage of wastewater is reused in the factory, and how to manage the wastewater that cannot be reused?
Thank you. The answer is that all wastewater we are reused to the our all activity, but we separate which kind of state of wastewater that we recycling to the system. And I show in the beginning in my slide that water is treated to comply with the standard of discharge to the public canal. That quality of water is tested and verified by the system is same or better than quality water in natural canal already. Then can say that 100% of wastewater are recycling by the first use is we use for the green area that by the regulation of developing, we have to provide 30% of the area to be a green area and common area. And the rest of that, the 70% is used for factory. So we use this water to reduce the natural water from the resource. If we don't have the recycling system, we just pump or draw from the resource that we have a limited quantity in the dry season. So this is the first thing. The second thing is that when we produce the reclamation, reclaim water by reverse osmosis, actually the quality is much better than the standard of provincial power authority of Thailand. That because of the criteria of reverse osmosis membrane, they need feed water with higher quality than the power PWA standard. But the function of reverse osmosis is only remove the dissolved solid that we can see in the water from the water. So the result of the treated water or reclaimed water that will have a much better quality than the standard of PWA. But we need reverse osmosis because we have to remove dissolved solid in the water. So we supply this with the water supply system in general because we cannot separate the pipe distribution pipe because it's costly. We have the same standard of water to the with the customer, but the quality when we recycling is much better than the normal standard. Okay, this is the answer.
Okay, so we also have like the continuing question again. I think you answered already a little bit for this question. The first question is about for wastewater recycling. This treatment water is used for industrial or drinking water. And second question is if it is the drinking water, how to test some chemical contaminated in wastewater.
No, we are supply the industrial water use. Normally, drinking water have another criteria in terms of water, source of water, the packaging or the distribution system is totally different. Normal drinking water in Thailand, they almost use the bottled water. We don't have, I don't see anywhere in Thailand have the distribution, this system for drinking, except in Japan, in Singapore have the distribution system that comply with the water system.
As I have one more kind of very popular question for today. The question goes to Mr. Chusha. The wastewater recycling system is costly. So what is the payback duration from selling the recycling water?
No, if you ask for the payback, you have to see how it impact to the industry. If we say the cost is 10% more, but how much the impact over the 365 years when we got the DOS crisis. But actually, reducing the cost of operation and maintenance for the recycling with the energy we reduce the energy by use the energy cost. Actually, you pay by the normally, I think that's a double of the what we invest the clean energy in the system, like rooftop solar or floating solar, whatever. That is a cost reduction operation, and also selecting the for recycling water in the system. The key success factor is three things. The one is the process design for pre-treatment for RO membrane. You have understand clearly about what kind of the industry wastewater that you want to recycling. It's so different. Rubber industry, electronic industry, food industry, whatever. It have different process of pre-treatment for reverse osmosis membrane. Secondly, if you use the better technology, you can reduce the chemical consumption, power consumption, or operation cost. Then you have to have a good quality of equipment selection. You can say that $1 of equipment that you discount or you use a cheaper one, it can be damaged. You are 100 million baht to damage the membrane system. So that is the key point. The second, the third is you have to find the skilled operator to run the recycling system. In my experience, when we start the operate the recycling system, the first time we found that in 1 year we broke the membrane because the pre-treatment system is not suitable. It can be, but it normally the reverse osmosis system, the lifetime of the membrane is at least 5 years in financial model. But at that time, we just use only 1 year. It's broke already. It's clogged already. So that because of the skill of operator, they did it. Oh, it's very good process, but actually they kill the membrane already because they don't have skill. So the three key success factor is that you have to use the designer that understands clearly about the characteristic of wastewater for that industry. Secondly, the process design have to make the suitable for the industry. The third is the selection of quality of equipment and skill operator. That is the point of the key success factor. Okay, that is all the answer.
Okay, thank you very much, Jas. We have a very short period of Q&A today, so please be sure that all of the questions will be sent to our speakers. And I have to say that that's all for the time we have for questions today. Thank you very much again. We really appreciate your time and expertise on today's topic. And also thank you to everyone in the audience. We appreciate your attention and participation. Now let's get back to our MC today, Ms. Munaprat. Thank you very much.
Okay, so thank you very much. It seems like 2 hours is a little bit short with very informative webinar that we have today. I also would like to thank you, our speakers and moderators, for sharing their expertise and plan and technologies about the water management. We know a lot about the policy and the plan and the technology that we can apply to our business. And also, I would like to have a special thanks to the Federations of Thai Industry, Water and Environment Institute for Sustainability, for provide the content and bring together all the speakers with us today. So for the WEIS is also our conference partners for the ThaiWater Expo, which will be organized in Bangkok, Thailand. So make sure that you follow us on our social media channels, both on Facebook and also from LinkedIn. So you can have an update of the activity that we have during the ThaiWater. Okay, so after this webinar, so there will be the survey sending to your email. So make sure you let us know how is the webinar today. And also if you wish to know more about the water, what kind of topic you are expect us to provide you next time. So I think this is all for the Thailand sessions for today, but we are not all for today yet, because we are in the afternoon, we will be having the Malaysia sessions starting at 1:30 p.m. in the Thailand time and 2:30 in the Malaysia times. So the topic will be about the proposed changes in the WSIA for water reclamations and resource recovery. Very interesting topic, so don't miss that. Okay, at the end, so I would like to thank you everyone once again. So stay safe, everyone. Thank you. ขอบคุณค่ะ